Alright, here goes. So this video is going to walk you through how to do some of the constructions in the Matching Angles Part 3 activity. I'm going to start with construction 5 because my guess is you were able to get 1, 2, 3, and 4 on your own. If any of those gave you trouble, we can review those when I'm back. Alright, so starting with construction 5, it says construct two congruent angles with their vertex as the center of two congruent circles. So before we start actually doing our constructions, let me just give you a picture of what it is that we're aiming for. So what we would like to have is two congruent circles. We're going to do the actual constructions, but we have circle A and circle B. And we're looking for two congruent circles. And within those, we would like to have two congruent angles. This angle and this angle would have the same measure. So that's kind of what we're aiming to construct. Two congruent angles with their vertex as the center of two congruent circles. Okay? So that's what we're aiming for. So how do we do that? Well, first we need to have two congruent circles. It doesn't matter in this case what size their radius is. So the first thing that I'm going to do is I'm going to set my compass open to a particular radius. And I'm going to draw one circle. And then, so I know it's a little hard to see on this visual, so I'm going to trace over it with a slightly darker marker. I just use my compass to construct one circle, and that was its center, and I'm going to call this one circle A. And then, leaving my compass open the same amount, I'm going to construct a second circle over here. And again, I know it's a little hard to see what landed there. Here is my second circle. I'm just tracing over what was drawn in pencil that doesn't show up very well. And there's the center, B. Okay. So there are my two circles, circle A and circle B. What I'm going to do first is within circle A, I'm going to create an angle of an arbitrary size. That just means it's an angle of no particular size. I don't know what the measure is, but it doesn't really matter. Okay. So now I have this angle that I've created, and I'd like to copy that angle into circle B. Well, I can place the first side of that angle. It doesn't really matter the orientation of it. I can place the first side of the angle. What I need to do now is to use my compass to determine exactly where the other side of that angle in circle B needs to go. So in order to do that, I'm going to use my compass to measure the span across that arc there in circle A. And I'm just going to make a little construction mark here so that I know. Again, I know it's really hard to see these construction marks, but I just made a little arc that looks like that with my compass. And then without opening or closing the compass, I'm going to pick it up and I'm going to transfer it over to the other circle. And I'm going to mark a little arc that intersects that other circle. And I made that arc just like that. Okay. Now what I can do is I can take my straight edge and I can connect the center of circle B with the intersection point of this arc. And now I have constructed two congruent angles inside two congruent circles. So that's construction number 5. All right, next we're going to work on constructions 6 through 11. So these are actually a sequence of constructions altogether. Number 6 says construct two overlapping circles where the circles are the same size and pass through each other's center. So I'm going to mark the center of the first circle. I'm going to call that one A. And I've switched over to a pen in my compass here, so hopefully I'll be able to see this a little better. And I'm going to go ahead and create this circle. This is circle A. Now, it says I want a second circle, and I want the second circle's edge to pass through the center of the first circle. So what I'm going to do is essentially turn my compass around, and I'm going to orient it so that the new circle passes through the center of the other circle. And right there was where I marked that one, so I'm going to call the center of that B. Okay? So that's construction 6, 2 overlapping circles whose centers pass through each other. For step 7 then, it says to construction 6, add another congruent circle that overlaps with either of the first 2 circles and passes through the center of one of the circles. So what I'm doing is, without opening my compass or closing it any further, so I've got the same measure, I'm going to create a third circle that passes through the center of one of these. So I'm just going to place the drawing point of my compass on the center of circle B, and I'm going to make a third circle there. So there's my third circle. That one was centered at this point here, and I'm going to call that point C. Ooh, actually my directions tell me to call this one O. Okay, so now we've done construction 6 with the 2 overlapping circles. We've done construction 7 where we added a third circle. In step 8, it says label the center of the circle that has 2 overlapping circles through it, point O. Okay, so I actually labeled these things wrong. I want this to be O and this to be B as I'm following my directions. Okay, so this is the center of the circle that has the 2 other circles passing through it. That's O, and the other 2 circles are A and B. All right, so that's step 8. To construction 8, we're going to add rays that start at point O. So I'm going to take my straight edge and start at point O and pass through A. So there's ray OA, that's one. And then another one that starts at O and passes through point B. That's ray OB. Okay. So now we have angle AOB. Angle AOB. So that one's done. All right, then it says to construction number 9, so what we already have here, we're going to add a ray that starts at point O and passes through the intersection of the other 2 circles. That's circle A and circle B. That's this point here. So from O out through here. And it tells us then that this forms what's called the angle bisector of angle AOB. What that means is that this new ray that I just created bisects angle AOB. And in this case, bisects means it cuts it into 2 equal angles. So it cuts angle AOB into 2 equal angles in half. That is the angle bisector. Then it says, draw an angle first and figure out how to use the same construction steps to bisect your new angle. So what I would suggest you do is pause for a little while and work on step 11. If you're unable to get it, if you're unable to figure that one out, go ahead and restart the video and I'll show you how to do that. Okay, you've probably been trying for a little while to figure out how to construct the bisector of a given angle. So we have a particular angle here. This is angle AOB. I have no idea what its measure is. I just drew it using my straight edge. But what I'd like to do is to bisect that angle. That is, I'd like to draw in the ray that cuts that angle exactly in half. So what I'm going to do in order to do that is first, I'm going to place the center point of my compass on the vertex of that angle. And I'm going to make an arc that intersects both rays. Oops, I lost it a little there. You can see I have 2 intersection points, this point here and this point here. And what I know now is that this segment, I'm going to call this point C and this point B. Segment OC is congruent to segment OD. Those are 2 radii of the same circle. It's a circle centered at point O that has a radius of whatever I open my compass up to. Okay? And again, I don't need to know what that radius is in particular. The next thing I'm going to do then is I find it's helpful if I open my compass up just a little bit more. Now I'm going to center it at one of those 2 points. In this case, I'm going to center my compass at point C. I'm going to draw a decently big arc out in space here. And without changing the measure in my compass, I'm going to center my compass again, but now at point D, and make another arc out here. Now we have, I'm going to call this here point E. So if we think about it, line segment CE and line segment DE are the same length as each other because those two line segments are radii of congruent circles. What I need to do then to finish bisecting my angle is simply to connect point E, that is where those two circles overlapped, with point O. And that segment, OE, or that ray OE, is the bisector of angle AOB. It cuts that angle into two congruent angles. It bisects that in half. I'm going to suggest that you practice the steps for bisecting a given angle on your own for a little while. And then if you need help on steps 12, 13, 14, 15, and 16, you can resume this video. All right, we're resuming with construction 12. And the first thing it says is repeat construction 6 and construct two overlapping congruent circles that pass through each other's centers. So I've done that already here. Step 13, it says, to the previous construction, draw a line that passes through both centers of the circles drawn. So all I need to do is take my straight edge and draw the line that passes through the center of those two circles. That's step 13. Step 14, it says, now add a line that passes through the two intersections formed by the circles. So here's one point where the circles intersect, and here's the other point where the circles intersect. Now, I can connect those two and create that line. And what it tells us is that the lines that we just constructed are in fact perpendicular. So these are the steps to construct a perpendicular pair of lines, or to construct a 90-degree angle. So it is possible to construct an angle that has a measure of exactly 90 degrees. So here's my question for you then. If you know how to construct an angle that has a measure of 90 degrees, can you also construct an angle that has a measure of 45 degrees? Well, if you think about it, in the previous step, you learned how to bisect an angle. That means cut it into two equal angles. If you can construct a 90-degree angle, and you can construct the bisector of that, then you can also construct a 45-degree angle. Think for a minute about what size angles it's possible to construct and what size angles it's not possible to construct. So here, I've shown you the way to construct a 90-degree angle. Remember, in your little constructions booklet, one of the things that you did was you constructed an equilateral triangle. I'm going to sketch, rather than construct, an equilateral triangle here, because you did, in fact, construct one before. So here's your equilateral triangle, and it's possible to construct that with your compass. If you remember that all three angles inside an equilateral triangle are congruent to each other, and that the angles inside a triangle have to add up to 180 degrees, we know that each of these angles must be 60 degrees. So you have already constructed some 60-degree angles. If you have the tools to construct a 60-degree angle, can you construct a 30-degree angle? Well, sure, you construct a 60-degree angle and then you bisect it. So you have the tools to construct, and again, I'm going to sketch it, but you could actually construct it. You are able to construct an angle that has a measure of 30 degrees by constructing an equilateral triangle and then bisecting one of its angles. If you can construct an angle of 30 degrees, can you construct an angle of 15 degrees? Sure, you can construct the bisector of this. So you have the tools to construct an angle of 15 degrees. So a question then is, do you have the tools to construct an angle whose measure is exactly 75 degrees? That's the thing I want you to think about and be ready to answer. Can you construct an angle of 75 degrees? To help you with constructions 15 and 16, it's important for us to understand what it means to say that a line is a perpendicular bisector. So first I'm going to do some sketches to help you understand what that phrase perpendicular bisector means. If we have a line segment, segment AB, a perpendicular bisector has two important characteristics. The first is that it is perpendicular to this segment. It forms a 90-degree angle with this segment. The second is that it's a bisector. A bisector divides this line in half, so it's going to pass through the midpoint. So a perpendicular bisector would look like this. It would have two characteristics. It would be perpendicular to segment AB, and it would bisect it in half. Just to clarify some things that are not perpendicular bisectors, we can have a line that passes through the midpoint that is not perpendicular. In this case, this line that I've drawn, I'm going to call it line L. Line L is a bisector of segment AB, but it is not a perpendicular bisector because it doesn't form a right angle. I can also create another line. I'm going to call this one line K. Line K is perpendicular to segment AB, but it does not pass through the midpoint. It is not a bisector. Okay? So only this first line that we drew is a perpendicular bisector. This one is not perpendicular, and this one is not a bisector. All right, so the question then is, given a particular line segment, how can we construct the perpendicular bisector? Well, if we repeat steps 12, 13, and 14, here's what we can do. We can take this segment and we can draw one circle that is centered at point A and another one that is centered at point B. I think I got a little floppy on one of these, so I'm just going to clean this one up. Yeah, that's better. Okay. And all I have to do to finish making the perpendicular bisector is to connect the intersection points of those two circles together. This is both perpendicular and it bisects segment AB. Okay. So that gets you all the way through construction 16. I would suggest you want to have some notes, and again, you can do them in whatever format makes sense to you. It doesn't have to be a booklet, about how to construct an angle bisector, how to construct congruent angles, and how to construct a perpendicular bisector. All three of these are things you may be asked to do on your performance task.